In this question, it says a cone which is 8.4 centimeter high, and that means the height of the cone is known to us, and the radius of the base is given as 2.1 centimeter, is melted and recast, that means reshaped into a sphere. We have to find the radius of the sphere. So what we can do, we can make a cone first. Let's say I made a cone here. Let's this be the cone, and then it is melted and reformed in the shape of a hemisphere or sphere, sorry. It is recast into a hemisphere. So when one object is reshaped or recasted, it always, their volumes remain same. That means if I say that, let's say the volume of this figure as V1 and this figure as V2, their volume will be same. Now, what else we have? We have more information here. That means the height is known to us, the height of this. Let's say this be the height and this being the radius. What we know here, we know the height here. And how much is the height given as? Height is given as 8.4 centimeter. That means we can write H as 8.4 centimeter. And the radius of the base, I'm using this radius as a small r to indicate the radius of this base, and the radius is given as 2.1 centimeter. The radius of this base is 2.1 centimeter. Now we have to find the radius of this sphere. Let's say the radius of this sphere, I'm using capital R to denote this. Let's say capital R. Now, as I said that their volumes are same, so we can replace this V1 and V2 with their respective formulas. The volume of a cone is 1/3 pi R square H. You should be careful about using the symbol here. The small r indicating the radius of the cone, and not that of the sphere. And for sphere, the volume is 4/3 pi R cube, where the R is capital R. That's why I'm writing capital R cube. This is what we have to get. Now we can reduce this. As you can see here that just 3 and 3 get cancelled. Even pi and pi get cancelled. Now we'll replace this with their values. I can see R as it is 2.1. So I will be writing 2.1 whole square, or you can write 2.1 into 2.1. The height, which is given as 8.4, that is equal to capital R, that is 4 times capital R square. Further, you can reduce this number. That means this is divisible by this. This is 4/3 pi R cube. Now, this is not pi R square. This is pi R cube. Now, I can reduce this number by 4, that is 2.1. So finally, if I rewrite this, I'll say that it is 2.1 into 2.1 into 2.1 is equal to capital R cube. Now, in the next step, we can write this as a cube of 2.1, that is 2.1 whole cube, which is equal to R cube. Thereby, we can say that R is 2.1 centimeter. That is what we have to calculate. The more important thing that is whenever we reshape one solid figure into another, their volumes remain same, right? And not their surface area.